Assalamu alaikum, dear friends. Here I am your further mathematics teacher. Here we have a question is about the topic is mathematical induction, and this is the question is about 92311111 October November 20. In this question, we have to apply three. We have to apply mathematical inductions. It has a three cases. Um, One case, second case, and third case. First number of cases, I write it into this one, P of n, which is d 2n minus 1 dx 2n x sine x equal to minus 1 n minus 1 into x cos of x plus 2n minus 1 into sine of x. Here we have to apply our first case. Let n equal to 1. We have to apply it. P of 1 t 2n minus 1. 2 1 minus 1, it will be 1. Dx, it will be also 1. Here similar sine x. Here we take its left hand side. Know how to deal this one. This is your first function and this is your second function. We will apply it by using simple derivative methods. U dot v. What is the formula of u dot is? U dot v, u derivative of v plus v derivative of u. Similar, x is same, derivative of sine x, it will be cos x plus cos sine x, and x derivative will be 1. Now we will take its right hand side. Where is right hand side? This is our right hand side, at which I have highlighted it. Now put n equal to 1 in right hand side, minus 1, n minus 1, it will be 0 into x cos of x, 2 into 1 minus 1 up to sine of x. Now minus 1 power 0, we know that any power 0 answer will be 1. Here x cos of x plus 2n minus 1, it will be 1 sine of x. These are the similar. So left hand side equal to right hand side. Now we will put here second condition, which is n equal to k, where 2k minus 1 dx 2k minus 1. This will be also minus 1. Minus 1. Okay. Sorry. X sine of x. Similar, we put n equal to k in above equations. Minus 1. K minus 1. What's the k value is? K minus 1 into x cos of x plus 2k minus 1 into sine of x. Okay, we have this is our second condition. Now put our third condition, k plus 1. We have to apply n equal to k into this equation. Here this one is this at here. Now d 2 k. We have k plus 1 minus 1 divided by dx 2k plus 1 minus 1 x sine of x. Now minus 1 k plus 1 minus 1 x cos of x plus 2 into k plus 1 minus 1. We will apply k plus 1 in above equation. over main equation. Now, um, we have to prove this one. We have to prove. We have take its left hand side. What will be the left hand side? 2k plus 2 minus 1, it will be plus 1. Yes. Dx 2k plus 2 minus 1, it will be 2k plus 1. Uh, now we have to deal first this side, x sine of x. How to deal this one? How to deal this one? Uh, in this case, could we write it into this one? D square into dx square into d 2k minus 1 divided by dx 2k minus 1 into y. How? Look at this one. This is our power 2. This is our power 2. And this is our 2k minus 1. If you solve these two equations, we get this one. It's very easy. Further, we will go d into, okay, if any problem, okay, dx square. Um, how to deal this one? This is, we have to solve it. We will solve it into dx square. And what's the value of its value? 2k minus 1 is similar here. This one, same this value are here. Progressing. Now we will going forward. What will be the d square? Dx square minus 1 par k minus 1 and into x cos of x plus 2k minus 1 into sine of x. Okay. Now we will again going toward in this way. We will take its first derivative minus 1 k minus 1 at its start, and we take first time derivative and first and second derivatives remaining. We will have to x cos of x. Its derivative is cos of x minus x sine of x plus 2k minus 1. Here sine x derivative will be cos x. Okay. Minus 1 k minus 1 dx derivative is minus sine of x, and x cos of x derivative is x cos of x derivative is x, sine derivative is cos of x plus cos x derivative is 1 and sine x is similar plus 2k minus 1 sine x derivative is cos x derivative is minus sine. Here we just change the sign. Cos x derivative is sine of x. Now further going toward minus 1, k par is minus 1, and here minus is everywhere. Here is minus, here is minus, here is minus. This minus will be common at the start. Here sine x is positive sine x. Here plus x cos of x plus sine of x. This is plus 2k. 2k sine of x, because here minus minus these are cancelled outside and all the values will be positive. Okay. Now 2k minus 1, 2k multiply by sine of x and minus 1 multiply by minus sine of x. Here sine of x and sine of x, these are cancelled with each other, and minus 1 par k minus 1 plus 1. This minus 1 and plus 1 will be cancelled because these, as indices rule, bases are same, power will be add. Okay. Now x cos of x is same as it is. And here in these two, sin x is common. The answer will be 2k plus 1. So this is our required form. This is same required form. It's our right hand side, which is equal to right hand side. This is showing that we have completed these questions and we have to prove pk plus 1 is true. So three conditions are completed. We have proved this question by using mathematical induction. Thank you so much. Thank you so much.